Hi everyone, and welcome back to AWS Jolie. We are continuing our new playlist where we are talking about the machine learning fundamentals needed for the AWS Certified Machine Learning Engineer Associate exam. And we're going to jump into task statement 3.3 and pick up where we left off. In the last lesson, we finished task statement 3.2. So the third task statement for the machine learning engineer associate exam guide is to use automated orchestration tools to set up CI/CD pipelines. So let's start this lesson and jump back to our last lesson where we were talking about how to apply best practices to enable maintainable, scalable, and cost-efficient machine learning solutions. And let's pause for our fundamentals and dive deeper into machine learning ops. We mentioned this under task statement 3.1. Machine learning ops or MLOps is a practice that unifies machine learning application development with machine learning system development and operations. And you can use MLOps to automate and standardize processes across the machine learning lifecycle. These processes include model development, testing, integration, release, and infrastructure management. And AWS has their very own MLOps workload orchestrator solution that can help you enforce architecture best practices for machine learning model production. And while we're talking about fundamentals, let's go back to our fundamental lesson that we keep coming to. At the beginning of our machine learning lifecycle and for MLOps, we have the first two steps of the machine learning engineer lifecycle, and that is to collect and process data. So this is your data preparation. You collect data of different types from various sources and then perform activities like aggregation, duplicate cleaning, feature engineering, and more on that data. After you use that data to train and validate the machine learning model, you can then deploy the trained and validated model as a prediction service that other applications can use or access through the APIs. So exploratory data analysis often requires you to experiment with different models until the best model version is ready for deployment. It leads to frequent model version deployments and data versioning. Experiment tracking and machine learning training pipeline management are important before your application can integrate or consume the model in your code. MLOps helps us to manage the release of new machine learning models with application code and data changes. A MLOps implementation uses the machine learning assets similar to other CI/CD environment software assets. You deploy machine learning models with the applications and services they use as part of a whole process. In our last lesson, we mentioned version control. After you have your CloudFormation template definition file, you can commit that file to a source code repository such as S3 or GitHub. Then your CI/CD pipeline can be automated to run when a new version of a file is committed to the source control repository. And for your exam, dive deeper into using code repositories in your deployment environments. Let's ask a quick question. Could you use Code Pipeline to deploy code maintained in a repository to a single Amazon EC2 instance? You could. Your pipeline is triggered when you push a change to the repository, and then the pipeline deploys your changes to an Amazon EC2 instance using Code Deploy as the deployment service. You can also use Code Pipeline to orchestrate each step in your release process. Each stage of your CI/CD pipeline is structured as a logical unit in your delivery process. Each stage acts as a gate that vets a certain aspect of the code, and as the code progresses through the pipeline, the assumption is that the quality of the code is higher in those later stages because more aspects of it continue to be verified. Problems that are uncovered in early stages stop the code from progressing through the pipeline. Results from the test are immediately sent to the team, and all further builds and releases are stopped if the software does not pass that specific stage. The steps in code pipeline are commit, build, and deploy stages. You could deploy a CloudFormation template in the build stage that saves the template stack to an S3 bucket. And then in your deploy stage, you could have the CloudFormation template deploy the code from Amazon S3 containing the application API endpoints using Sagemaker endpoints. The CI/CD pipeline is built using AWS Code Pipeline, and it uses a continuous delivery service that models, visualizes, and automates the steps required to release your software. And by defining stages in our pipeline, you can retrieve code from a source code repository, build that source code into a releasable artifact, test the artifact, and then deploy it into production. Only code that successfully passes through all of these stages will be deployed. And you can optionally add other requirements to your pipeline, such as manual approvals, to help ensure that only approved changes are deployed into production. AWS step functions can also be used to orchestrate your workflows and can handle nested workflow logic, errors, and retries. Ensure you understand how to integrate and configure other AWS services into Code Pipeline to complete your machine learning pipeline, and also understand the set of AWS CI/CD developer tools that AWS provides. Let's continue on with test statement 3.3, which is to use automated orchestration tools to set up CI/CD pipelines. So for this exam, also ensure you know how, when, and why to use the different deployment methods such as blue, green, canary, immutable, rolling with batch, and more. What are some deployment strategies for serverless? Well, AWS CloudFormation, AWS Serverless Application Model, or AWS SAM, but also all at once, blue, green, and canary or linear. One basic deployment strategy in serverless is to update your function code in production, publish a new version, invoke the version directly to run your integration test against it, and then after everything looks good, you can flip the alias that your production uses to point to that new version. Now the traffic will shift instantly from the old version to the new version, and in production, we want automated deployments and controlled traffic shifting. AWS provides code deploy with different deployment strategies. So for the exam, make sure you dive deeper into these different deployment strategies and deployment types. It also lets you monitor the deployment and have alarms where you can initiate the rollback if something goes wrong. So code deploy will help you deploy your new versions using different strategies such as linear or canary. It can also define pre-traffic and post-traffic hooks. These functions can help you to verify that the newly deployed code is configured correctly and your application is working as expected. As you scale your machine learning operations, you can use Amazon Sagemaker managed workflow services to implement CI/CD practices for your machine learning lifecycle. With the Amazon Sagemaker model building pipelines and the Sagemaker Pipelines SDK, you can choose and integrate pipeline steps into a solution that automates the model building process from data preparation to your model deployment. For Kubernetes orchestration and Kubernetes-based architectures, you can install Sagemaker operators on your Kubernetes cluster to create Sagemaker jobs using the Kubernetes API and command line Kubernetes tool such as kubectl. For Sagemaker notebook jobs and to schedule non-interactive batch runs on your Jupyter notebooks, you can use the notebook-based workflows service to initiate standalone or regular runs on a schedule that you define. Sagemaker notebooks can run Jupyter notebooks, which are configuration files with different cells that have the enriched text and code cells that you can execute. In notebooks, models can be trained, saved, loaded, and run. There are environments or kernels inside the notebooks, and similarly, if you were developing code on a local machine, it is best practice to have multiple environments set to ensure you are working in isolation from other environments and from the machine. When you create a Sagemaker notebook, you need an instance role to interact and have access. Sagemaker notebooks also have a feature to integrate with Git. And remember earlier I said that Sagemaker is a collection of services and features? Well, it also holds a collection of notebooks, documentation, and examples that you can use to create your own code or project. And for the exam, make sure you understand how to secure your access to Sagemaker notebooks. You can also use other AWS services such as Airflow workflows and step functions that integrate with Sagemaker to build your workflows. For Airflow workflows, the Sagemaker APIs export configurations for creating and managing Airflow workflows. And for step functions, you can use multi-step machine learning workflows in Python that orchestrate Sagemaker infrastructure without having to provision your resources separately. Here's another question. Let's say you have existing infrastructure. How do you select the correct deployment orchestrator in AWS? One solution is to use Amazon Managed Workflows for Apache Airflow, which is a managed orchestration service for Apache Workflow that you can use to set up and operate data pipelines in AWS. Apache Airflow is an open source tool used to programmatically author, schedule, and monitor sequences of processes and tasks referred to as workflows. With Amazon MWAA, you can use Apache Airflow and Python to create workflows without having to manage the underlying infrastructure for scalability, availability, and security. Amazon MWAA automatically scales its workflow execution capacity to meet your needs, and it integrates with AWS services to help you provide fast and secure access to your data. You can also use Sagemaker Model Building Pipelines, which is a tool for building machine learning pipelines that directs Sagemaker integration. You can create a pipeline and set up Sagemaker projects for orchestration using a tool that handles much of the step creation and management for you. For functions that act as an orchestrator, calling other services and functions and coordinating the work, this can result in idle time in the function and increased costs. Moving the orchestration flow to AWS step functions creates a more maintainable and resilient state machine and can help you reduce costs. You can also automate data ingestion with AWS Data Exchange and send the data to Amazon S3. AWS Data Exchange helps you to securely exchange file-based data sets in AWS. The way that it works is you subscribe and find hundreds of data sets from data providers. Then you can download the data set or copy it to an S3 bucket. Then you could use the data with the AWS Analytics and machine learning services. This pattern provides AWS confirmation templates that enable you to automatically ingest that data from AWS Data Exchange into your data lake in Amazon S3. Let's continue with task statement 3.3 and pause and go back to fundamentals and talk about how Git flow involves creating multiple levels of branching off of a main branch where changes to feature branches are only periodically merged all the way back to the main branch to trigger a release. When Linus Torvalds introduced Git version control in 2005, it changed the way we thought about branching and merging. In 2010, Vincent Dreisen introduced Git flow, which became a popular branch and release management model. It introduced the concept of develop branch as a mainline as a mainline integration in the main branch, which is always kept in a production-ready state. So for the exam, ensure you understand how to implement CI/CD with the AWS developer tools, and let's bring back CloudFormation. Remember, you can use CloudFormation templates to set up the required roles and environment for the main and develop branches, including your repository, your Amazon VPC, your instances, your code build, your code deploy, and the code pipeline. So for this test statement, also ensure you understand writing and running unit tests in your development environment. What services can we use for testing? In AWS, test environments can be set up in minutes, and it's only pay for what you use. So you can easily spin up your test environment and then tear it down when the testing is completed. Dive deeper into AWS SAM, code pipeline, and CloudFormation, and dive deeper into automating your test environments. Compiling and testing the code is the continuous integration part. Producing an artifact from your code that is ready to be deployed is the continuous delivery. And deploying the application automatically is the continuous deployment. Code quality testing begins when the code is checked out from the source code repository. If you compile your code will be tested to see if it can create a fresh build environment. Then you run unit tests to configure your CI/CD tool to execute the tests that are in your code base. So let's ask a quick fundamental question. What is the point of unit tests? It is to ensure that the unit tests pass, but also that the tests are maintained and enhanced as your code base grows. Then your code is packaged and you can run acceptance tests to ensure the code does what it should do and meet all of your requirements that were established in your design document. Once the tests are complete and passed in your pipeline, it can then move to the delivery or deployment stage. And when you add automation to your test, it can speed up the whole pipeline and deployment and reduce risks. Ensure you have depth in testing and fundamentals. Let's move on and talk about automating unit tests and code coverage. We just mentioned having the need for unit tests and testing. A good practice to test how services interact with each other is to write integration tests, especially for serverless applications that mock the behavior of services in AWS. When testing your serverless applications end-to-end, it is important to understand your user and data flows and your user interface too. Tests can be configured using AWS Lambda. AWS Glue provides both visual and code-based interfaces to make your data integration easier and can be integrated to unit tests, Python scripts for your Glue jobs, and deploy AWS Glue jobs using code pipeline. Let's say that you have migrated your application to AWS and you're using code pipeline. Your application has a test environment and a production environment that are all configured in your pipeline. You want to ensure that any issues that are identified before the deployment for new updates, revisions, or versions. What steps can you take? Well, this scenario is a bit vague, but what I'm hoping you're thinking is to add a test action to the pipeline for both unit and functional testing using AWS Code Build. Then you verify the test results passed before moving on to the deployment. You could also use AWS Code Deploy action to deploy that latest version to a pre-production test environment, set up manual approval actions in your pipeline to have the needed test perform, and then have another code deploy action that deploys that verified code to your production environment. For running load stress tests, performance benchmarking, and application testing at scale, check out the AWS prescriptive guidance for load testing applications. Let's wrap up this task statement and talk about how to configure training and inference jobs in your CI/CD pipelines. There are additional considerations for expanding your pipeline, such as metadata management, experiment tracking, and monitoring your implementation for your continuous integration and continuous deployment processes, such as automated retraining, scheduled inference, and similar extensions of the pipeline. So here is one solution. And in AWS in cloud, there are always different solutions. So if you have a different solution, please let me know in the comments below. I'm always interested in how people approach different scenarios. But for my solution, you can develop the initial machine learning model and evaluate its inference performance with Jupyter Notebooks. You can then integrate the model with runtime Python scripts so they can be managed and provisioned by a machine learning framework using Amazon SageMaker. The development of runtime scripts so that the model can be incorporated into SageMaker, and these standalone Python scripts include predefined SageMaker callback functions and different environment variables. Remember, they are all run inside a SageMaker container that is hosted on an Amazon EC2 instance. For processing jobs, SageMaker provides two options for performing batch mode model inference. You can use SageMaker processing job or a batch transform job. Each option has advantages and disadvantages, and we talked about those in earlier lessons. A processing job consists of a Python file that runs inside a SageMaker container. The processing job consists of whatever logic you put in your Python file. Batch transform jobs are an extension of the concept of a SageMaker endpoint. At runtime, these jobs import callback functions, which then handle the I/O for reading the data, loading the model, and making your predictions. AWS recommends running Python runtime scripts locally before you deploy them into AWS. And then you can use the main guard clause when you structure your Python scripts and perform your unit test. Then you define your pipeline. With SageMaker, you can use AWS step functions or MLOps framework, which also supports other pipeline or state machine systems such as Apache Airflow to drive the development and deployment of machine learning pipelines. You can define the input and output placeholders for each step of the pipeline with a focus on training, inference, cross-validation, and back testing. Then you can create the underlying infrastructure using CloudFormation and include the AWS step function state machine instance or Airflow. You can also prepare metadata and data locations to fill in concrete values for your input-output placeholders that you defined, including the runtime scripts and model hyperparameters. Then you run your pipeline and implement continuous integration and continuous deployment processes, automated retraining, scheduled inference, and similar extensions of the pipeline. And then you monitor. What can you configure to monitor for any SageMaker model state changes? What can you configure to monitor for any SageMaker model state changes? You can use Amazon EventBridge to monitor status change events in SageMaker. EventBridge helps to automate SageMaker and respond automatically to events such as model state changes, training job status change, or endpoint status change. Events from SageMaker are delivered to EventBridge in near real time, and you can write rules to automate actions to take when an event matches a rule. Another solution would be to use Amazon SageMaker Feature Store for training and inference. Feature Store offers a central repository of feature values that can ingest, store, and share standardized features from batch and streaming data sources. Feature Store organizes your features in groups, and you can use the SageMaker Feature Store API or SageMaker Studio to add features to your feature group. You can ingest different types of data into SageMaker Feature Store, including streaming data from sources such as application and service logs, click streams, and sensors. And they also include tabular data from sources such as S3, Amazon Redshift, AWS Lake Formation, Snowflake, and Databricks Delta Lake. With Amazon SageMaker Data Wrangler, you can publish features directly into SageMaker Feature Store. And With the Apache Spark connector, you can batch ingest a high volume of data into a single line of code. And that wraps up task 3.3. And in our next lesson, we're going to move on to domain 4, which is machine learning solution monitoring, maintenance, and security.